Hi everyone, Assalamualaikum. In this video, we are going to continue with extremum points under partial derivatives. Now we look at example 2 from the previous semester papers. Find the critical points of fxy equals to 2x squared plus y cubed minus x squared y minus 3y and determine the nature of the points. Alright, to solve this question, first step, we need to find all the first and second partial derivatives. Alright, means we need to find fx and fy for the first partial derivatives. And we need to find fxx, fxy, and fyx, fyy for second partial derivatives. Alright. To find fx and fy, we differentiate from f equals to 2x squared plus y cubed minus x squared y minus 3y. Okay. Alright, from f here, we can find fx. Fx means partial derivative of f with respect to x. From f here, we treat x as a variable. So to avoid error and easy to differentiate, we can write variable x in different colors and we put variable x at the back. Okay. At the same time, we treat y as a constant. Alright. Then we can find fx. When we differentiate 2x squared, we get 4x. When we differentiate y cubed, y is a constant. So y cubed is also constant. When we differentiate constant, it equals to 0. Okay. And then from here, we have y constant and x squared is variable. If we have multiplication between constant and variable, we just keep the constant in front and then we differentiate the variable. So when we differentiate x squared, we get 2x. Okay. And then to differentiate 3y, y here means constant. Okay, constant times 3 equals to constant. And when we differentiate constant, it equals to 0. Alright. After that, we simplify. So we get, from here, we get 4x minus 2xy. Alright. So this is our fx. Okay. And then we find fy. Fy means partial derivative of f with respect to y. So from f here, we treat y as a variable. And at the same time, we treat x as a constant. Since we treat y as a variable, so to avoid error and easy to differentiate, we write y in different colors. And we put y at the back. Okay. Alright, then we can find fy. Okay. When we differentiate 2x squared, now we treat x as a constant. So when x squared constant and then times 2 is also constant, when we differentiate constant, it equals to 0. Okay. And then y cubed is a variable. So when we differentiate y cubed with respect to y, using power rule, we get 3y squared. Okay. And then to differentiate y squared is a constant and y is a variable. When we have multiplication between constant and variable, we just keep the constant in front. Then we differentiate variable y equals to 1. So we get x squared here. Okay. And then to differentiate 3y with respect to y, okay, we will get 3 here. Okay. Then we simplify, we get fy equals to 3y squared minus x squared minus 3. Alright. Right, after that, from fx, we can find fxx. Okay. Fxx means partial derivative of fx with respect to x. Okay. From fx here, we treat x as a variable, and at the same time, we treat y as a constant. Alright? So to avoid error and easy to differentiate, we can write variable x in different colors and we put variable x at the back. Okay? Then we can differentiate fx with respect to x, which is f(x)(x). Okay? When we differentiate for x, it equals to 4. Okay? And when we differentiate constant x, okay, 4 is also constant. When we differentiate for x, constant x, the answer equals to constant. So same goes to constant 2y times x here. When we differentiate, we get constant 2y. Alright? Alright, then we also can find fxy from fx here. Fxy means partial derivative of fx with respect to y. From fx here, now we treat y as a variable. And at the same time, we treat x as a constant. Okay? Since we treat y as a variable, so to avoid error and easy to differentiate, we can write variable y at the back and we use different color for variable y. Okay? Then we can differentiate fx with respect to y and the symbol is fxy. Okay? When we differentiate 6x, now we treat x as a constant. So 6x is also constant. When we differentiate constant, it equals to 0. Okay? And when we differentiate 2xy, 2x here is constant. So constant y, when we differentiate, it equals to constant. Alright? Alright, from fy here, we can find fyx. Fyx means partial derivative of fy with respect to x. Okay? From fy here, we treat x as a variable. And at the same time, we treat y as a constant. Okay? So when we find fyx, when we differentiate 3y squared means constant. So when we differentiate constant, it equals to 0. Okay? And then when we differentiate x squared with respect to x, okay, x here is variable, so we get 2x. Okay? And when we differentiate constant 3, it equals to 0. Then we simplify, so we get fyx equals to negative 2x. Right? Alright, then after that, we can find fyy. Fyy means partial derivative of fy with respect to y. Okay, from fy here, we treat y as a variable. And at the same time, we treat x as a constant. To avoid error and easy to differentiate, we can write variable y in different colors. Okay? Then we can find fyy. When we differentiate 3y squared, y now is a variable. So we will get 6y using power rule. Okay? When we differentiate x squared, okay, x now is a constant. So when we differentiate constant, it equals to 0. And when we differentiate 3, 3 is also constant. It equals to 0. Alright? Then we simplify, so we get fyy equals to 6y. Okay? Alright, from here, we get fxy equals to negative 2x. And we get fyx equals to negative 2x. Okay? So from here, we have fxy equals to fyx. Okay? So we can use this concept to check if our derivative is correct. Okay? If our derivative is correct, means the value of xy must be equal to the value of the function of fyx. Okay? . after we find all the first and second partial derivative in step 1, we can continue with step 2. Okay? Step 2, find the critical points when fx equals to 0 and fy equals to 0. Okay? From the previous slide, we get fx equals to 4x minus 2xy. Alright? Then, when fx equals to 0, okay, so we equate 4x minus 2y equals to 0. Then we can divide both sides by 2. Then we get 2x minus xy equals to 0. Okay, 0 we divide by 2 equals to 0. Okay, then we naming it as equation 1. Okay, and we can factorize x here. So in bracket we get 2 minus y equals to 0. Okay, so now we have multiplication between two functions equals to 0. Means that x equals to 0 and 2 minus y or 2 minus y equals to 0. Okay, this comes from equation 1. Okay, then we get values of a and x and y. So we can naming it as 1a and 1b. Okay. Alright, so from here we get x equals to 0 and 2 minus y equals to 0. Okay. Then when we solve, we get y equals to 2. Alright. And then we equate fy equals to 0. So from fy equals to 3y squared minus x squared minus 3, when fy equals to 0, so 3y squared minus x squared minus 3 equals to 0. Okay, then we can naming it as equation 2. Alright. After that, we substitute x equals to 0 from here into equation 2. Okay. From equation 2 here, we substitute x equals to 0. We just substitute the value of x. Okay. We substitute the value of y later. Okay. Now we substitute the value of x first. Okay. Alright, so from here, we have 3y squared minus, we replace x by 0. So 0 squared minus 3 equals to 0. Then we get 3y squared minus 3 equals to 0. Okay. We divide by 3. So we get y squared minus 1 equals to 0. Y squared equals to 1. And y equals to plus minus square root of 1. Okay. Alright, so we get y equals to positive 1 and y equals to negative 1. Okay, when we have y squared here, we need to put plus minus sign here so that we will get complete value of y. Okay. Alright, so from here, after we substitute the value of x into equation 2, then we substitute the value of y. Okay, y equals to 2 into equation 2. Alright. So from equation 2, we have 3y squared. Okay, now we replace y by 2. And then minus x squared. And then minus 3 equals to 0. Okay, then we simplify. We get 12 minus x squared minus 3 equals to 0. And 9 minus x squared equals to 0. Okay. So we will get x squared equals to positive 9. And x equals to plus minus square root of 9. Okay. Remember, if we have x squared here, so we must put plus minus when we find x. Okay. Alright. So that we can find all values of x. Okay. So from here, from x equals to plus minus square root of 9, so our x equals to 3 and x equals to negative 3. Alright. Then we can find the critical points. Okay. The critical points are, point here means we need to write in terms of coordinate. Okay. Alright. When we have x equals to 0, we get y equals to 1. Okay. So the first critical point, okay, is 0 and then 1. Okay. And then when x equals to 0, y equals to negative 1. So the second critical point is 0, negative 1. Right? And then when y equals to 2, x equals to 3. So the third critical point is 3. We write variable x first. Okay? We write x first and then y equals to 2. So the coordinate is 3, 2. Okay? And then the last critical point, when y equals to 2, x equals to negative 3. So we write coordinate of x first. So we get negative 3, 2. Okay? So these are the critical points. Okay? We have 4 critical points. Okay? If we just write positive value here and here, we only have 2 critical points. Okay? That's why it is important to write plus minus sign when we solve y squared and x squared. Okay? So that we will get complete answer. Right? Alright, after we find all the critical points, we can continue with step 3. Okay? Find D, where D equals to fxx times fyy minus fxy bracket squared. Okay? From the previous slide, we get fxx equals to 4 minus 2y and fyy equals to 6y. Okay? And we get fxy equals to negative 2x. Okay? Then we can find D using this formula. Okay? Alright, D equals to, we replace fxx by 4 minus 2y. Okay? And then times, we replace 4yy by 6y. Okay? And then minus, we replace fxy by negative 2x here. Okay? Then we expand and simplify. So we multiply 6y by 4 here. So we get 24y minus 6y times negative 2y. So minus 12y squared and then negative squared. So we get positive y squared, and outside bracket we have negative sign here. Okay? So minus 4x squared. Okay? Never multiply negative and negative here, because negative here we need to solve squared first. Okay? So after we simplify, we get negative 4x squared, not positive 4x squared. Alright? So you must be careful. Okay? Alright, after that, we can continue with step 4. Use table of sign for D and fxx. Right? So from the table of sign, okay, we use table of sign for 4 columns here. Okay, first column is critical point. Second column is D. Third column is fxx, and the last column is for conclusion. Alright? We have 4 critical points, okay, which is 0, 1, 0, negative 1, 3, 2, and negative 3, 2 from the previous slide. Okay? Then we can find D. Okay? So we replace x equals to 0 here and y equals to 1 here and here. Okay? So we get 24 times 1 equals to 24 minus 12 times 1 equals to 12 minus 4 times 0 equals to 0. So after we simplify, we get 24 minus 12 minus 0 equals to 12. Alright. And then for critical point 0, negative 1, D equals to, we replace Y equals to negative 1 and we replace X by 0. So we get 24 times negative 1 equals to negative 24. And then negative 1 squared equals to positive 1 times negative 12 equals to negative 12. And then minus 4 times 0 equals to 0. Then after we simplify, we get negative 36. Alright. Okay, then for critical point 3, 2, our D equals to, when we substitute here, okay, so we get negative here, okay. And for critical point negative 3, 2, when we substitute Y equals to 2 and X equals to, Y equals to 2 and X equals to negative 3, we get this value, right? And then for column fxx, okay, we only have variable y here. So we just substitute variable y into fx here, fxx here, okay. So y now equals to 1. So when we substitute here, so we have 4 minus 2 equals to positive 2, okay. So means positive sign, okay. And then for critical point 0, negative 1, we replace y equals to negative 1 into here, okay. So we get 4 plus 2 equals to positive 6, means positive, okay. Alright, then we replace coordinate 3, 2 into fxx here. So we only have variable y here. So we replace 2 into variable y. So we get 0, okay. And for the last row, we replace y equals to 2 into fxx here. So we get 0. Alright. Then we can make a conclusion, right? So from here, we have D, okay, D is 12. 12 means positive. So now we have D equals to positive, okay? And we have fxx equals to positive, okay? So means if we have fxx positive, means we get smile graph. Smile graph means minimum point, okay? So we can write the conclusion is minimum point, alright? And then for the second critical point, we have D equals to negative value. So from here, D negative, okay, so no need to check fxx because if D negative, so the conclusion is saddle point. Okay, so no need to refer fxx, okay. When D negative means we have saddle point here, okay. And then from the third critical point, we also have D negative value, okay. So when we get D negative value, so from here D negative, so we will get saddle point, okay. And then for the last critical point, D is also negative value, okay. So when D equals to negative value, we will get saddle point, alright. Alright, so we can write a conclusion, okay. Step 5, give the conclusion either maximum or minimum or saddle point, alright. Minimum point, okay, from here equals to coordinate 0, 1, okay. And then saddle points are, we have 3 saddle points here, okay. 0, negative 1, 3, 2, and -3, 2. Right? So this is the final answer. Right? Determine the nature of the points. The nature means we need to identify whether the points is maximum, minimum, or saddle point. Alright? Coming up next, more examples for extremum points. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.